Okay, so they're going to work this one first, so pay attention. And the video is going, so... Okay, here we go. Two numbers. That's a 5. And factors. You make the denominator the coefficient of x. Yes. Almost. Almost. Shh. Okay, look. You have factored it, but you have not solved it. It's set equal to 0. So at this point, you would set each of the factors equal to 0 and solve for x. Okay, you do. So for this one, to solve for x, what would you do? You would subtract 4 on both sides, and so your first solution would be x equals negative 4. That's an x-intercept for this parabola. To find the second one, we can't just simply look at this and then flip the sign because there's a coefficient on the x. So what do you have to do to solve for this x? Add 3. And so 2x now equals 3. And then you divide by 2, and you end up with x equals 3 over 2, or 1.5. Which, look above. Isn't that just the opposite of what it was before you moved the 2 to the front? It was a minus 3/2, and now we end up with a positive 3/2. Okay. Now let's look over the second one, which you don't have to write. I just want you to watch. Okay, so this one is the same thing. You have a number in the a place that's greater than 1, but unfortunately it's not the GCF because you can't do 11 divided by 5, you'll get a decimal. Same thing with 1 divided by 5, you'll get a decimal. So you have to use the same method where you multiply the a times the c, and that will give you 5. And that's the number you're trying to multiply to get. And you're trying to add to get what number? Negative 11. 5 is what kind of number? Prime. So the only two numbers that multiply to make 5 are 5 and 1. Itself and 1. Now, can you get an 11 with a 5 and a 1? No. So, this one does not work with the a times c method. So, today we're going to learn a new method to solve it called the quadratic formula. I think you'll think it's easy as long as you're paying attention. Now, the quadratic formula is the formula over there on the whiteboard. See on the whiteboard? That is the quadratic formula. Don't worry, it's easier than it looks. Okay, so now, and you will be given that formula on the test in this class and on the EOC. So you just have to know when to use it and how to use it. You don't have to memorize it. Okay, the quadratic formula is a formula that can be used to solve any quadratic equation. Even the most basic ones, where you're just trying to look for two numbers that multiply and add, say you struggle sometimes finding those two numbers, you can do the quadratic formula and it will give you the answers. 13. Yeah, we're skipping 12. Go to 13. Yeah, you can. We'll never go back to it. Look at it and then look at 13. It's like a repeat. It's just 13 has more on it, so we're going to do it. Okay, so the quadratic formula is a formula that can be used to solve any quadratic equation, any equation where the highest exponent is 2. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. You do. Well, yes, you do. Okay, now, you're going to use it when your a on a trinomial is greater than 1, but where? A is greater than 1. AC. It's also written on the whiteboard if you can see it better on the whiteboard. Okay, so we are going to use the quadratic formula when your a value in the trinomial is greater than 1, but the a times c method does not work, like the one we just tried on the warm-up. You can try it, or you can just do quadratic formula. But yeah, if you want to try the a times c method, you're going to have to at least multiply them and then see if there's a number that produces that number and adds to get the b. Or if you don't feel like even trying that, you can just go straight into the quadratic formula. Okay, so how do we use it? That's what I'm about to show you. So as soon as I feel like everybody's finished copying this, I'm going to zoom in right here. Okay, we ready? Okay, let me zoom in. Okay, so here we go. Steps for using the quadratic formula. Number 1, set the equation equal to 0. Well, look at this example. Isn't it already set equal to 0? So for this one, step 1 is done. Step 2, identify the a, the b, and the c. What is the a value in that trinomial? 1. What is the b value in that trinomial? And what is the c value? 3. So before today, the first thing you would have done if you saw a problem like this is you would have started racking your brain for two numbers that multiply to 3 and add to 5. But those numbers, they exist, but they're not whole numbers. Because think about it. The only way to get 3 is 3 times 1. And then a 3 plus 1 is not going to make a 5. So that's why we have to use a new method. Now, yesterday and the day before, we learned a method that would solve this called completing the square. But in a minute, I'll show you why completing the square is not the best way to go with this one. So now we're going to do quadratic formula. So we've identified the a, b, and c. Now we're going to do step 3, find the discriminant. The discriminant is b squared minus 4ac. And isn't that the part of the formula that's up under the square root? Okay, that's called the discriminant. Okay, so b squared minus 4 times a times c. So what do I plug in for the b? What do I plug in for the a? And for the c? 3. Now in your calculator, just type that in, parentheses and all. 5 squared minus 4 times 1 times 3, but make sure you put the parentheses. Okay, once you've typed it in, what do you get? 13 is correct. So 13 is our discriminant. So hold on, I'm going to write it as soon as the pen wakes up. Oh no, it's slow. Well, okay. For this particular one, if you don't have the parentheses, it would be okay. But if it's ever negative and you don't put parentheses, it'll be wrong. So that's why I just always say put parentheses, stay in the habit of it. Now, whenever your discriminant ends up a number greater than 0, like ours did, because 13 is greater than 0, that lets you know that we're going to have two solutions. Okay, anytime your discriminant is a number greater than 0, you're going to have two solutions. Now, to find those two solutions, you continue on with the quadratic formula, where you're going to substitute in A and B into the parts that we haven't dealt with yet. So x equals, isn't the formula, look on the whiteboard, negative b? Well, if our b is a 5, won't that mean we'll have a negative 5 now? Plus or minus the square root of b squared minus 4ac, which we already did, and it gave us 13, divided by 2 times a. And our a is, so 2 times 1 will become a 2. So now we've substituted in. Now to find the actual solutions, you're just going to type in negative 5 plus the square root of 13 over 2 and negative 5 minus the square root of 13 over 2. Now, since that's a fraction, I'm going to do it by using alpha y equals n over d. Okay, so here we go. Negative 5 plus the square root of 13 and then over 2 is negative 0.697, so I'll just round that to negative 0.7. Now, since there was a plus or minus sign, now I'm going to type it in a second time, but instead of a plus, oh, and I forgot alpha y equals n over d first to set up for a fraction. So alpha y equals n over d. And now I'm going to do it again, but instead of a plus right here, I'm going to use the minus from the plus or minus sign. The square root of 13 over 2. So my solutions are negative 0.7 and negative 4.3. And they're approximations because I rounded. Okay, now I'll give you time to copy and then I'm going to show you something. Okay, ready? The first thing I'm going to show you is the graph of this parabola. X squared plus 5x plus 3 is a quadratic equation because the highest exponent is 2. So it's going to produce a parabola. So x squared plus 5x plus 3. Okay, we know a parabola is a U-shape, so normally they cross through the x-axis in two places, just like this one did. And what were our two solutions? Negative 0.7. Well, look, this is 0, this is negative 1. So wouldn't that place be negative 0.7? And then wouldn't this place over here be the negative 4.13? Wouldn't that be negative 4.3 because it's a teeny bit past negative 4? Okay, now let me show you something else. Don't write this, just look. This is enrichment. Remember, we were trying to factor, but we couldn't think of numbers that were whole numbers that multiplied to 3 and added to 5. If negative 4.3 is your final answer, doesn't that mean before you actually set it equal to 0 and solved, it would have been x plus 4.3? And then wouldn't this negative 0.7 have been x plus 0.7? Now look, isn't 4.3 plus 0.75? And type in 4.3 times 0.7 and see what it says. Right, it's like 3.01, right? So those are the two numbers that multiply to 3 and add to 5. We just could not do them by factoring because we couldn't think of those numbers because they weren't whole numbers. So we had to do it by a new method called the quadratic formula. Okay, now, we could have attempted this one by complete the square. So I don't want you writing this, I just want you watching. What was our first step yesterday for complete the square? Move the constant over. So that would be this 3, so to move it over we would subtract it. And now you have x squared plus 5x. I'm going to go ahead and leave the blank where we're going to add in a number on both sides and then equals negative 3 plus blank. How do I now fill in that blank? Right, you take your b, which is 5, divide it by 2, which will be 2.5, and square it, which will be 6.25. And I think one of y'all actually asked in this class, or maybe it was another class, what about if your b causes a decimal or fraction when you divide it by 2? Was that this class? No, maybe 7th. Okay, now look, just like yesterday, these two just combine, and that becomes a 3.25. And on this side, you factor it. Now, this is special. This is a perfect square trinomial, so the factors will match. The numbers that add to 5 and multiply to that are 2.5 times itself. Because think about it. The whole way we got this 6.25 was 2.5 squared, right? So 2.5 times itself is that. 2.5 plus itself is that. Now, since it's the same, you write it once and square it. That's called a binomial squared. And now our goal is to solve for x, to get x by itself. So we now cancel out the squared by square rooting, and then we square it this side. So we have x plus 2.5 equals plus or minus the square root of 3.25. And now the remaining step to get that x by itself is subtract that 2.5 away. And so now type in the square root of 3.25 minus 2.5 and the negative square root of 3.25 minus 2.5. Everybody type that in. And then that, was it negative 4.3? Did you type in the square root of 3.25 and then minus 2.5 on the outside? Okay, and isn't that one of the solutions we got a while ago with the quadratic formula? Now type in the negative square root of 3.25 and then minus 2.5 on the outside. Negative 0.7, which is what we got with the quadratic formula. You put it outside. Which is right. You should get negative 4.3. You just typed something wrong then. It always goes outside. Okay, now, so you see that we could work this problem by either method, complete the square or quadratic formula. But in my opinion, for y'all, quadratic formula is the better route, because whenever your b is an odd number and then you go dividing it by 2, you end up with decimals, which will become harder for y'all to work with. So that's why sometimes, even if you can complete the square, quadratic formula might be the better answer. All right, now let's try the next example. And some of y'all need to wake up or you're going to be behind. Okay, what is step 1? Set it equal to 0. Well, right now it equals negative 8. So how can we make a negative 8 a 0? Add 8. Okay? So I have 2x squared minus 8x. If I add 8 to this side to cancel it out and make it 0, don't I have to add 8 over here? Well, it doesn't actually combine with either one of those, so you just tack it in on the end. Okay, now we're going to do the quadratic formula. So what do we do? Well, first, identify A, B, and C. What is the A? What is the B? And what is the C? Okay, now we find the discriminant, which is b squared minus 4ac. And that will be a negative 8 squared minus 4 times 2 times 8. All I did was plugged in the b value, the a value, and the c value, and now you type it in. Make sure you have parentheses, because this is one of those scenarios where if you didn't, it'll be wrong because you're squaring a negative. Zero. Remember on the previous example, our discriminant was greater than 0, and that produced 2 solutions. When your discriminant is equal to 0, the equation is going to produce 1 solution. Okay, so a discriminant greater than 0 produces 2. A discriminant equal to 0 produces 1 solution. Now let's find that 1 solution by continuing on with the quadratic formula. x equals negative b. But your b is already negative, so it will become positive. Then plus or minus the square root of b squared minus 4ac, which we now know is just a 0, divided by 2 times a. And what is your a? So that will make a 4. Okay, but now look up there. What is the square root of 0? So is 8 plus 0 or 8 minus 0 going to do anything? No, so just ignore it, and aren't you basically just left with 8 over 4, which is 2, and that's your one solution? Because my b was already a negative 8, so when I plugged it in the formula, a negative 8 became positive 8. Because the formula is negative b, so if your b is already negative. I do have a pen. It's blue. Okay. Is everybody finished copying? Do you see why it worked out that we only had one solution? Because of that 0 basically canceling out, and so we couldn't do plus or minus, because plus 0 minus 0 is going to do the same thing, right? Okay, now I'm going to work it a different method other than quadratic formula. I'm doing this for enrichment to help those of you who are smart become even smarter. No, enrichment is just when like I go beyond the lesson. Like remediation is when you go backwards and you like cover things again because they didn't get it. Enrichment is when you teach a little bit more. Yes. Okay. But just watch. It's not like it's something big. Just watch. Okay, so say that I got to that part, like once I've set it equal to 0 by adding the 8 over, and I look at it and I'm like, wait a minute, I don't want to do quadratic formula because what do I notice? No, you don't even need to do a times c because there's something easier. Look, what is your a value? Your a value. And look at all those. All 3 of them are divisible by 2, so there's a GCF. Because I just want you to see something. Okay, so now look. When you divide that by 2, you're left with x squared. When you divide that by 2, you're left with negative 4x. And when you divide that by 2, you're left with positive 4. Now, like we did when we were learning this, I see that I have a new trinomial that I can factor by looking for 2 numbers that multiply to 4 and add to negative 4. Negative 2 and negative 2. They match. So remember, at this point, you would have set each of those factors to 0, and that would not make any sense. You would set this one equal to 0 and end up with x equals positive 2. But when you set this one equal to 0, you would end up with, which is why you only have one solution. No, you can do all of them by quadratic formula. I just want to tie it all together and show you that it's all connected. It's not like totally different stuff. It's just different ways to solve it. And you choose the way that works best for you. Yes? Where did this 8 come from? It was on this side and I added it over to this side. I did on this side, but remember, if you add 8 on one side, you have to add 8 on the other. You have to balance the equation. Okay, now look. Shh, pay attention. Remember how normally a parabola, which is a U-shaped graph, crosses the x-axis in 2 places? Because it'll like come down, hit the x-axis, and then it'll go back up and hit somewhere else. Which is why normally we have 2 solutions. Well, let's graph this and figure out why there would only be one solution. 2x squared minus 8x plus 8. 2x squared minus 8x plus 8. Okay, we're trying to figure out why this parabola would be different and only have one solution. Because what does it do? Does it ever actually pass through the x-axis? No, it just comes down, hits at negative 2, bounces off, and goes back up. That's called multiplicity. You have 2 solutions but at the same location, so it's basically one solution. It's a multiplicity of 2. That's why you only have one solution, though. Does that make sense? Okay, now let's look at the next example. No, not yet. You're not ready quite yet. All right, number 3. The first thing we got to do is set it equal to 0. So on the left, I have 2x squared. I want the right side to be equal to 0. So wouldn't that require canceling out the negative x by adding it? And if you add it on this side, you got to add it to this side, so plus x. And then wouldn't that require adding the 1 to cancel it out? So we got to add it on this side. And now we have it set equal to 0. You're basically just picking up the terms and moving them across the equal sign, but when doing so, they change their sign. Okay, now, you could try other methods, or you could just jump right into the quadratic formula. So if we do that, what is the a, b, and c? Correct. All right, now we do the discriminant, b squared minus 4ac. So that would be 1 in the b place squared minus 4 times 2 in the a place times 1 in the c place. Now calculate that. What? Are you talking about the a times c method? Well, if you try the a times c method, 2 times 1 equals 2, so you're multiplying to get 2, and you're adding to get the b, which is 1, because there's an understood 1 in the b place. And the only numbers to multiply to get 2 are 2 and 1. And you can't add those and get a positive 1. And if you tried to change this to a negative to make that work, then it won't work up here. So this one cannot be factored by any method, which is why we got to do quadratic formula. You can't do the complete the square either, because we only learned how to complete the square when your a is 1. And in this case, a is 2. So what do you get for your discriminant here? Negative 7. Okay. So we learned that when the discriminant is greater than 0, you have 2 solutions. When the discriminant is 0, you have 1 solution. And when the discriminant is less than 0, like this one, you're going to have no solutions. Okay, now let's see why that would happen. When you continue on with the quadratic formula, x equals negative b, that would be a negative 1, plus or minus the square root of b squared minus 4ac, which we now know is negative 7, all divided by 2a, which will produce a 4. In your calculator, type in the square root of negative 7. What does it say? Right. You cannot take the square root of a negative number. We discussed that at some point last week, because remember, the reason the square root of 16 equals 4 is because 4 times 4 is 16. You're never going to multiply a number by the exact same number, though, and produce a negative answer, are you? So that's why you cannot take the square root of a negative, and that's why this one ends up no solution. So basically, if you're working on this worksheet today and you do the discriminant and discover it's a negative number, you don't even have to write this part. You just go ahead and write no solution. Now let's look at what that means graphically. Okay, 2x squared plus x plus 1. Okay, 2x squared plus x plus 1. Is that what it was? Oh, it was minus 1. Okay, it's going to be a parabola because it's a quadratic equation, because the highest exponent was 2. Oh, that's not the right equation. 2x squared plus x plus 1 was right the first time. Oh, no. Once I set it equal to 0. Hold on, of course it's froze. Squared plus x plus 1. 2x squared plus x plus 1. The graph will look like this. What do you notice about that parabola? But it never hits the x-axis, which is why there's no solutions. Because aren't the solutions the x-intercepts? And there aren't any. So that's why it's no solution. Well, they've been shifted up, and then they open up, so they never hit the x-axis. Okay. All right, go to the next page. Okay, number 1, quadratic formula. First, we identify the A, the B, and the C. What is the A? What is the B? And what is the C? -5. Then you take those numbers and you plug them in the discriminant formula, which is B squared minus 4 times A times C. In the B place, we put a -7. In the A place, we put a 2. And in the C place, we put a -5. Now calculate that so you'll know what your discriminant is. Okay, what do you get? I got 89. Y'all didn't get 89? Let me type it in. -7 squared minus 4 times 2 times -5. So y'all did get 89? Okay. All right, 89 is the discriminant, and that is definitely a number greater than 0, so we are definitely going to have 2 solutions for this problem. To find the 2 solutions, you just continue on with the quadratic formula, and you do -b. But our b is already negative, so what's going to happen? +7. Plus or minus the square root of your b squared minus 4ac, which we already know is 89, divided by 2 times your a, which is a 2, so that will become a 4. Now to find the actual answers, which are going to be approximate because you're going to round, you type it in twice, once with a plus, once with the minus. Use alpha y equals n over d to set up the fraction. 7 plus the square root of 89 over 4 and 7 minus the square root of 89 over 4. For the plus square root of 89, I got 4.1. And then when I do the 7 minus the square root of 89, I get right. What'd you say, Naya? Yes. Type in 7 plus the square root of 89 over 4. I mean, you could type in the square root of 89 plus 7 over 4, and that's the same thing. All right, let's look at number 3. This will be the last one. Shh. No, not tonight. Okay, look. Just like always, even though we now know how to do the quadratic formula and we could solve it, you should always check to see if there's factors. Are there numbers that multiply to -108 and add to 12? Yes. Hurry. What numbers multiply to -108 and add to 12? Start dividing 108 by even numbers in your calculator. That won't make a 12 though. Anybody got them yet? Anybody? Anybody? What's 108 divided by 6? No. 18. So it's a positive 18 and a negative 6, because 18 minus 6 is 12. 18 times -6 is -108. Well, if these are the factors, aren't the final solutions going to be a -18 and a +6?